Have you ever seen a trilobite? More than 500 million years ago, these arthropods roamed the earth, leaving record of the diversity in the form of fossils. So you wouldn't have actually seen one. You would have seen an imprint of their remains, or perhaps a hardened version of one. Over 17,000 of these species of trilobites helped scientists learn more about the law of superposition and the sequence of events in Earth's history. In this lesson, we're going to define fossils, discuss how fossils are dated, and state why they are so important. So first, what is a fossil exactly? A fossil is a preserved impression or remains of past organisms in rock form. Any preserved evidence will do. Paleontologists study fossils. Though almost 99% of the species on Earth have become extinct, only a small percentage of those species are preserved as fossils. So why are they so useful? For one, fossils can be dated and used to put together a picture of extinct communities. And two, they help to form a timeline of life on Earth. So how do paleontologists use dating techniques to determine the age of fossils? Well, two ways we're going to describe here. For one, scientists use relative dating, meaning they determine the age of rocks in relation to others through the law of superposition. Okay? Law of superposition states that the older a fossilized remain of an organism, the further down it will be located in rock layers. And this is because sedimentary rock builds in layers with younger layers of rock deposited on top of older layers. One more technique is called radiometric dating. Radiometric dating uses knowledge of the half-life of isotopes. Carbon-14 is a common isotope used. This is used to determine the age of a rock where the fossil was found. So how does this work? So we take a look at the graph, and we look at half-life as the amount of time it takes for half of the original isotope to decay. Okay, so let's look at one half-life down here on the x-axis. If we look up, this is where the parent isotope, or carbon-14, has decayed about 50%, or 50% is left. And the daughter isotope over here, which is commonly nitrogen, an isotope of nitrogen, nitrogen-14, is also at 50% of its isotope left in its composition. So when we look at this fossil, we can, if there is 50-50 proportion of each of these isotopes in it, then we know that they have reached one half-life. And then we can uncover and calculate the ratios and uncover the age of the rock. So why do we care? Well, for centuries, evolutionary biologists have been trying to uncover the mystery of species formation and extinction. Further evidence for species that may have existed millions of years ago, such as the trilobite, but that we might have no record of today, can explain all these key gaps in human evolution or in organismal evolution altogether. So remember, in summary, the law of superposition states that the older the fossil, the lower down in the sedimentary rock layers it will be. And radiometric dating uses isotopes, commonly carbon and nitrogen-14, to determine the age of rock based on their proportions in the rock.